In this program, we'll tell the story of space capsule Tycho Deep Space I, the second generation space capsule developed by Copenhagen Suborbitals in the period of 2011 to 2012, led by Christian von Bengtson.
I'm sitting here next to our space capsule Tycho Deep Space, also named Beautiful Betty. And this is our next generation space capsule in the more traditional geometry. It's about 500 kilograms, 2 meters in diameter, holding one person. This capsule was created to create some preliminary testing on main parachutes, hatch design, communication, but also seating design, where the seat has to obtain the forces to the astronaut during the launch and the splashdown on board. So this capsule here, which has been built and designed during the last 10 months, is supposed to be tested in the summer of 2012, doing a less separation engine test. And we are very excited to see, of course, how this capsule, which we expect to be the future designs of capsule here at Copenhagen Suborbital, how it's going to perform.
Unfolding the capsule reveals some of the key construction components. Testing the pressure hull and hatch sealing on ground before test flight is an important part of the capsule development. The capsule has to hold 1 bar of internal pressure, and the steel hull is checked for any leaks or deformation by inflating the capsule using outside pressurization bait. Covering the structure in a water soap solution will reveal any leaks, which can be marked and repaired later on.
The first testing we did on the hatch actually proved very well. We have just a very thin rubber sealing between the actual hull of the spacecraft and the hatch plate itself. And that system proves to be pretty okay so far. But just for like the initial testing, we have these very low quality sealing points beneath the screws here. But we're eventually going to replace those with a more solid system, maybe like a thin rubber seal. But for now, that's just, we have used this like low quality testing on the hatch, just actually to keep the pressure inside so we can see if there's any leaks.
In the spring of 2012, the capsule was drop tested at Lindø Industry Park for water impact evaluation.
Jamen, velkommen til. Tak. Stor dag. Jeg vil lige mens.
Vi har jo vores sidste nye skrig med i anden kapsel. Den står derude, og den kan vi selvfølgelig alle sammen kigge på i detaljer. Helt lavpraktisk, den vejer 450 kilo og er 2 meter i diameter. Og pointen i dag med den test, vi har, det er at smide den i et skråkast, som I nok har hørt om, for at se, hvordan tager den imod et slag på vand. Hvordan bevæger den sig rundt i vandet, hvad er dens flydeegenskaber, og hvordan kan man håndtere den.
The 110-meter high gantry crane at Lindø Industrial Park is a unique tool for performing various swing tests of the capsule from a height, simulating a capsule splashdown with its 3 main parachutes.
Men skal vi have overtryk i kapslen?
Ja, tak. Bare lige 0,2 eller noget. Jeg tror altså ikke, den har løftet sådan en millimeter hernede. Det er til sidst går i den situation.
Claus, det er standby, Claus.
Kapaciteten, er du det eneste derude, eller bare lige tjekker lige alle ud, så vi er sikre på, at folk er på plads.
Alle er klar, så tæller jeg ned. 3, 2, 1, 0.
Drop tests like these reveal how the capsule tends to stabilize itself in water and validate the structure and seed impact performance. For the capsule recovery divers, it was a great learning experience to handle a capsule in water.
This prototype capsule does contain 3 main parachutes which has been developed during the last 6 months. The parachutes, of course, is supposed to maintain for this capsule the correct terminal velocity when we have water splashdown. Two years ago we started to develop the parachute type for the spaceship Tycho Brahe. Early in the process we decided that the type of parachute we would try to produce should be the cross parachute, which in a way consists of 5 squares sewn together. The reason why we decided to use that kind of parachute is that you use all the material in World War II type parachutes, the round kind of parachutes. You cut the material in orange-like patterns, so you have a lot of waste and you have a much more complicated sewing process. With the cross parachute, the sewing process is really quite simple. The first parachute we made was a model just to see if it was possible to make something that worked. So we made a mock-up in about half the size that we eventually was using on the first spaceship, and it turned out it looked promising, so we went ahead and produced 3 45 square meter parachutes for the first spaceship Tycho Brahe. On the later parachutes, we have decided to try and modify them a little bit. And instead of having the arms of the cross parachute free, we have decided to sew the bottom of the parachute together so that in a way it's round in the bottom and still kind of a pillow-like shape seen from above. From the first spaceship Tycho Brahe to this less Apollo capsule we are making now, there's been a development in the construction of the parachute. On the first spaceship Tycho Brahe, the arms of the cross parachute were free, like a traditional cross parachute which is normally used for cargo or as a brake tube for aeroplanes. In the model we are producing now, we have been inspired by the new American military parachute, which is basically a cross parachute, but it is sewn together in the bottom so that there's more control of the parachute, and it's in essence round in the bottom and still has the pillow-like shape if you see it from above. The materials we use for the parachute is the same materials as the parachute you would buy from an ordinary parachute producer is using. It's the same fabric and it's the same thread, and every time we have some kind of sewing technical problem, we follow the standards that you use on hot air balloons, because the hot air balloons are in Denmark classified as airplanes or as airborne vessels, so there's a very strict procedures on how they should be sewn. So we use that as our default on how to produce the details.
The 3 main parachutes for Tycho Deep Space I has a combined drag area of approximately 120 square meters, providing a final capsule descent velocity of approximately 7 meters per second when splashing down in water. The total mass of the parachutes are 45 kilos.
So basically what we're trying to do now, if all goes well, is to put the parachute into its bag. And what we're going to do with the parachute is to make an S-fold where we take the bottom of the parachute and fold it up into itself, and on top of that S-fold the other way over it. And that is going to be a lot of folds, and in the end we're gonna squeeze them together and put them into this bag, which, as you might be able to see, doesn't hold a lot of volume. But if you take a look at the parachute, we have pressed out most of the air, and we have tested it a couple of times at this point, and we know that it will be able to come into this bag, but it takes a lot of hard work, so wish us luck.
Each parachute has its own distinguished pattern in white and fluorescence orange in order to validate the performance of each parachute after a test flight. The pyrotechnic system to perform drogue parachute deployment is tested thoroughly. If the drogue system fails, no main parachutes will be deployed and the capsule crushed in the ocean.
Drogue separation test 3, 2, 1. The effect of the explosion was far more aggressive this time. The last time it just barely came up like half a meter.
Later, the performance of the main parachutes was tested with a manned jump. Finally, the parachute system is ready for installation in the capsule. Installing all parachutes and the many liners is a slow process requiring full attention. The entire system has to be carefully placed in its correct sequence to ensure a smooth and correct parachute deployment. To fit all 3 main parachutes with the correct shape and density, vacuum packing is required. After 4 hours and many tryouts, the 3 main parachutes are finally installed.
Det sorte område, hvad er det så? Det er latterkastræk?
Det er selve motoren, ja. Det er brændstof, ja.
The launch escape system engine, which was tested in December 2011, is refurbished and reassembled. It's a high-power hybrid engine placed on top of the capsule and has the function of pulling the capsule away from any potentially failing main launcher. This launch escape system is a vital safety component of the Copenhagen Suborbitals manned flight.
Since this capsule is a prototype capsule, it doesn't obtain or doesn't hold all systems that it's needed for a final real manned spaceflight. It doesn't have any environmental and control life support systems because we're only going to fly our spacecraft dummy Randy. It doesn't have all the internal guidance systems because it's not needed for the less separation flight. But it does have the three main parachutes for the test and for the splashdown landing on water. It has uprighting balloons, which is supposed to make sure that the capsule has a correct orientation when it lands on water.
The 4 upright bags are essentially 4 big balloons concealed in the top part of the capsule, holding 250 liters. If the capsule stabilizes itself in an upside-down position, also known as stable 2, the balloons may be inflated using carbon dioxide and the capsule will flip over. Each balloon is carefully installed in the capsule with powerful attachment liners to the capsule. A thin aluminum plate covers each balloon, which will be forced out when the balloon is inflated. Between the balloon and the aluminum plate, there are protective fabrics to ensure no damage to the balloon itself.
There's been a lot of development on the seating on this capsule here, so we have a correct way of obtaining vibrations and oscillations for whatever engine is going to launch this type of capsule into space. Also internally we have the basic electronic systems. We have external and internal cameras, so we are able to live see what is going on during the flight, but also afterwards doing evaluations on, let's say, the man on the seat, how he reacts to certain types of acceleration.
For Tycho Deep Space we have 4 cameras, 2 on the outside and 2 on the inside in the space capsule, and 2 outside is pointing upwards, so we can film hopefully the parachute deployment, and 1 downwards just to film the ride of the spacecraft. And inside we have 2, one mounted on the crash test dummy and one filming the interior of the spaceship. And this is downlinked via a radio link in one picture, so we get a 4-tile pattern in the downlinked video. Of course we also record from each camera, so hopefully we will have HD recordings of all 4 cameras. In addition, we have a GPS antenna mounted on the space capsule. This is an experiment, and it's not because we cannot find the space capsule. It goes to like 1 kilometer, so that would be easy, but we are training ourselves and using this as an exercise to what can we measure with a GPS under these circumstances. In addition, we have a barometric pressure sensor, which we also would like to experiment with, maybe further on down the road we'll use that to measure the distance to the ground for parachute deployment or top dome release or whatever. All these data are collected in an onboard computer, a microcontroller, which stores them on a SD card, as well as send them down to mission control via our radio link. So we should be able to follow Tycho Deep Space all the way up and down, hopefully, and we are able to recreate the flight path of the space capsule quite accurately. In addition, we have an IMU, which is a gyro and an accelerometer inside the spacecraft to measure the attitude of the spacecraft during the flight, and of course the acceleration. This way we can also evaluate the performance of the LES rocket.
This capsule also has an uplink and a downlink system installed. The uplink radio system, of course, take the commands from the mission control ships, so we're able to separate the launch tower, deploy the drogues and the main parachutes, but also deploying the uprighting bags after a splashdown on water. The downlink system sends us preliminary data on its position, but it also gives us a live feed from the 4 GoPro cameras, so we're able to actually witness close from this capsule view here what is actually going on during the flight from the mission control panels.
I just wanted to show the small antenna is the video transmitter antenna. There's actually 2 on this spaceship. They are mounted diagonal, so one is here and the other one is up there. Those 2 are for the video transmission system, and they use 2 different frequencies in the same band, of course, and the receiving system contain 2 receiver antennas and 2 different receivers, and they automatically switch between the 2 systems, so we get the best possible signal, no matter how the aircraft is rotated and what about the angles and signals. So this is called a diversity system. The uplink command system is also a dual system. We also again have like 2 antennas again. This is more standard. We got 2 receivers, one there and one here. We then OR the signals together in a little unit, and then we act as if it was one signal. So it doesn't matter for the system if there's one good or another one is bad.
Like the previous spacecraft Tycho Brahe-1, this capsule also contains the special Copenhagen Suborbitals developed sequencers. These systems are able to take commands from the mission control ship and actually perform different kind of tasks. It could be deploying the parachutes, it could be separating the LES tower, or it could be to open up the solenoid valves for at least 100 seconds to deploy the uprighting bags. So these sequencer systems are a vital part of the internal brain of the capsule, and of course are installed this year as well.
En af de allerførste playmates, altså de her folde-ud-piger, som virkelig gjorde indtryk verden over, det var en kvindelig fotomodel, der hed Betty Page. Rumkapslen Beautiful Betty!
Raket fungerer virkelig til at redde kapslen, hvis motoren nede under den lange store, og den fejler.
4, 3, 2, 1, 0!
The separating of the top LES engine is very important. The capsule has to continue the flight by itself, and a stuck LES engine will eventually block any deployment of the capsule parachutes. This is done using 4 pyrotechnic bolts.
Last year Copenhagen Suborbitals flew a spacecraft called Tycho Brahe-1, and you may remember if you follow this project that it was a stick-like configuration where you were standing up. This was actually, from my point of view, a very beautiful configuration because it doesn't really get any smaller than that. However, we also discovered that there might be issues with this kind of configuration where you're forced to have your parachutes in the back and you're standing up. So we have decided to change the design a bit and actually move on to a more traditional kind of capsule here, where you're lying down on a more traditional basis and you have the parachutes on the top of the capsule. And of course we believe that the survival rate of this kind of capsule here is much bigger than the stick design spacecraft. And also it was kind of a need to do a different kind of design as well, because this type of capsule and the geometry is very beautiful. I find it very beautiful. So playing with these kind of geometries and creating this kind of space capsule here is actually, you know, a dream of not only myself but the rest of the team here to try and do something slightly different, even though it might seems to be more conventional.
Sputnik er i affyringspositionen. Flight her, modtaget, tak.
Spice, det er pas.
Flight her, kom ind, pat.
Jeg er klar til en radio-igniter-test.
Modtaget, tak.
Jeg har powered op på bus A, B og D som Daniel, og E-com flasher rødt, så det ser rigtigt ud.
Det er super. Noteret.
Jeg vil gerne bede om gå for arm af lidt.
Der er go.
Jeg er med nu.
Sputnik crew er klar til at evakuere. Det er modtaget. I hopper i rød ribben, og det er nødvendigt.
Flight pat.
Nej, det er kommet pat.
Tændkabel forbundet, og der er LED-status grønt.
Modtaget.
Trækker safety pull. Flight med pat.
Flight er kommet pat.
Sputnik er forladt, og jeg har safety cock her.
Det er modtaget, tak. og trækker i sikkerhedsafstand. Blå rip, go, no go. Go. Fido, go, no go. Go, no go. Data, go, no go. Hjortø, go, no go. Der er go for Hjortø. Leopold Rosenfeldt, go, no go. Leopold Rosenfeldt, go. Vi har et go for booster. Vi har fuld go nu. Vi har sendt ud til T minus 1 minut. 4, 3, 2, 1, go.
Og vi kører. Hold fast.
Det er fløjt her. Vi er stadig i live herovre og får lidt data fra kapslen. Du kunne godt tænke os at få lov til at køre quick-releasen, så hvis dykkeren bare lige kunne træde væk et øjeblik, nogle meter. Den er ufarlig, men burde kunne køre under vand, hvis den modtager radio. Jeg kører quick release system 3, 2, 1. Og er det smukt? Det virker stadigvæk.
Ja, blå rip.
Blå rip, kom ind.
Hvis vi skal have reddet motoren, tror jeg, vi skal give det første prioritet. Den hænger kun i det der jordbær der. Jeg er ikke sikker på, at den er stabil på længere sigt.
Modtaget. Jeg synes, det er helt fint. Gå og ordne motoren. Dive rip, flight. Kunne I tænke jer så en tur ind til kapslen? Jeg kunne rigtig godt tænke mig en inspektion på bunden af den, der stikker op, sådan så der ikke er huller, sådan så når vi laver ballontesten, så går den ned der. Flight, dive rip. Nej, jeg kan ikke dive rip.
Jamen, vi har fuldt en inspektion hele vejen rundt, og vi har som sagt en bold, der ser ud som om, der er på vej igennem, men det er et meget lille hul. Så der er et hul, og der vil trænge vand ind, men det er nok tvivlsomt for meget.
Who wants to clean up?
Så ser vi ikke noget loftet.
Ja.
This is the SD card. It might contain the data, but anyway, the card is still there.
Der trækker den.
Nej, det er den lille skærm, der bærer topkapslen.
Ja, det er den, du kan se.
Now we're back at the Copenhagen Suborbitals facility in Denmark after performing the last tests of Tycho Deep Space I. Since we managed to recover the capsule, we can now perform close-up inspections of the construction and all the subsystems, which is very important in trying to understand what actually happened during the flight, but also to see how did all the systems perform. As a general, just basic outline of the performance, we can conclude so far that the construction itself and the pressure hull actually performed as expected, even though it was badly treated by a rough landing at the sea. All electrical systems actually performed very well, except for the uprighting, the buoyancy inflatable bags. That system was actually crushed during the splashdown and could not perform what it was supposed to do after the splashdown. Since we had a unstable flight for the entire configuration with the LES rocket on top, we did not get the flight height we expected, and we did not get enough altitude for the main parachutes to fully deploy. So we yet have, I would say, testing to do on the capsule, because before I retire the capsule, I actually want to see the main parachutes being fully deployed to see if we get the terminal velocity as expected. So in the spring, maybe the summer of 2013, my plan is to drop this capsule from an airplane with a static line test, meaning that the main parachutes will be deployed immediately after leaving the space or the airplane, and we're just going to be landing the capsule on ground, solid ground, because it doesn't really matter. It's a final test just to see the parachutes, and it doesn't really matter if the capsule gets an extra deformation or two at the bottom. Tycho Deep Space I was a perfect testing of a prototype, and now I will begin the design and the production of the coming space capsule Tycho Deep Space II. Even though there's a slight change in the geometry and the overall diameter of the capsule, I can actually perform a technology transfer of all the system to those capsules I'm going to be building in the future. I'm going to be building a almost flight-ready capsule, which is going to be ready within the next 2 years. But in the meantime, I'm also going to be producing a boilerplate version, which is just a crude iron geometry for basic aerodynamics and future less testings on the capsule system. So full speed ahead, and we are continuing the process of the capsules here at Copenhagen Suborbitals.